One of the most important things you'll be doing throughout pretty much every one of your homeworks and on every exam is multiplying and simplifying fractions. So even if you already think you know how to do it, I would strongly recommend sitting and watching the rest of this video. So I'll start off with multiplying fractions. Most people are used to just multiplying fractions from left to right. Okay. So in this case, if you were to do that, 2 times 1 would give you 2, 5 times 10 would give you 50. There's absolutely nothing wrong with that method of doing it. Now, in this case, we can actually simplify this fraction. So I'll go ahead and explain how to simplify it. To simplify a fraction, you need to figure out in your head what number can divide into this top number and this denominator. In other words, what can we divide 2 by and what can we divide 50 by and still get a whole number for each one of those values? Well, if we divide 2 by 2, we would get a 1. If we divide 50 by 2, we would get a 25. So this fraction ends up simplifying to 1 over 25. And most problems will tell you to simplify your fraction or your answers. So that would be this answer for this problem. Okay, so again, there's nothing wrong with multiplying left to right, but sometimes the numbers can be pretty large and they would be more difficult to deal with. And that's what the second example is we can just multiply 12 times 15, but that number is kind of large and you would have to work it out off to the side. You would have to do that and you would multiply them together. So there's actually another way of doing this multiplication. So we have two fractions and we're multiplying them. What we're allowed to do is we can treat these numbers that are across from each other as if they were fractions. So like in this case, we can simplify 15 over 5. You could think of that as being 15 with the 5 at the bottom, except they're just diagonal to each other. So how many, if we focus on those two numbers, what number goes into both 15 and 5? Well, that would be the number 5, right? We can divide both of these by 5. What would the 15 turn into? 15 divided by 5, that would become a 3. What about 5 divided by 5? That would become a 1. So we simplified these two numbers that were across from each other, and we're able to do that anytime we're multiplying fractions, which again, you guys are going to see a lot in your homework. We can also do the same thing with this other diagonal. So if we were to look at the 4 and the 12, we can simplify them. And to do that, we figure out what number goes into both 12 and 4. Well, we can divide 12 by 4 and 4 by 4 as well. 12 divided by 4, that would give us a 3. And then 4 divided by 4, that would give us a 1. So it can look a little confusing, but if you look at our numbers, we have 3 over 1 and 3 over 1. At this point, we can multiply from left to right. So we can do 3 times 3. 3 times 3 gives me a 9 in the numerator. In the denominator, we'd have 1 times 1. 1 times 1 is just 1. And even though this is an answer and it is correct, you can simplify this because 9 divided by 1 is just the whole number of 9. So 9 would be the final answer. So here's another case in which doing that simplification with the diagonals will really help. Otherwise, you would be multiplying numbers from left to right and there would be extremely large numbers, especially in the denominator. We don't want to have to multiply 3 times 22 times 12. It'll just be a waste of time. So instead, what we can do is we can look at the diagonals like we did at the last problem. So we can look at 3 and 6 and we can simplify those two. Or we can do 11 and 12, 11 and 22. It doesn't matter which order you simplify them in. The important thing is that you choose one number on top and one number at the bottom. So like in this case, we would do 11 and 22. So what number goes into 11 and 22? That would be the number 11. So we can divide both of these by 11. 11 divided by 11 gives me a 1. 22 divided by 11 gives me a 2. So now we can go through the remaining numbers and it almost doesn't matter which order you do them in. Like you can simplify the 6 either with the 3 in this case or with the 12. But we're only going to choose one of those pairs. We're not going to use the 6 multiple times. So just for this example, I would choose the 6 and the 12. because I know the number 6 goes into both of those values. How many times does the number 6 go into the number 6? It goes into the number 6 one time. And then if we divide 12 by 6, 12 divided by 6 gives us a 2. So we're done simplifying those. The only thing left is the 3 and the 9. Now, even though the 3 and the 9, they're not like this, they're not diagonal to each other necessarily. One number's on top and one number's on bottom. So they're kind of diagonal to one another, just not directly, like they're not right next to each other. We can still simplify them though. So we can divide 9 by 3 and 3 by 3. Right? And I got this 3 from the idea that the number 3 goes into 3 and it goes into 9. 3 goes into 3 one time, 3 goes into 9 3 times. So if we look at all of the numerators, they're all smaller numbers now, and we can just multiply them together. 1 times 3 gives me a 3 for my numerator. And in the bottom, in the denominator, 1 times 2 is 2, times another 2 is 4. Because we had already simplified, like we already did this sort of crossing out, this answer is already as simplified as it can get. Now that's not always going to be true, but whatever's remaining, whatever your result is, it'll always be smaller than the alternative of just multiplying all numbers on top and all numbers on bottom. It's usually a lot harder to deal with that than doing it this way. So we'll do one more example of multiplication, and that is when fractions are in parentheses. So on the previous problems, I was using these dots as multiplication signs. But sometimes multiplication you'll just see with parentheses. So even in this example, everything's still being multiplied. They just don't have multiplication symbols, they have parentheses instead. But in this case, we can do the same thing. We can simplify the numbers that are diagonal to each other. So if we look at 15 and 2, we can't do anything to that because there's no number that goes into both 15 and 2. But we can look at the 3 and the 9. What number fits into both 3 and 9? Well, that would be the number 3. So we can divide both of these by 3. 3 goes into 3 one time. 3 goes into 9 3 times. So if we look at our remaining values, we can either simplify, well, there's only one pair. We can simplify 4 and 2, and then separately we can do 15 and 18. So we'll do 4 and 2 first. What number goes into both 4 and 2? Well, 2 fits into both of them, so we can divide both of these by 2. 2 divided by 2 gives me a 1. 4 divided by 2 gives me a 2. So the only thing left is this 15 and 18. What number can divide into both 15 and 18? Well, that number would be a 3. How many times does 3 go into 15? That's 5 times. And how many times does 3 go into 18? That's 6 times. So if we look at our numerators, the numbers that we have left, we have 5 times 3 times 2. 5 times 3 is 15, times 2 is 30. So we end up getting a bigger numerator, which is okay. We get a 30 on top, and in the denominator we get 1 times 6. That would be a 6. Okay, so even though we simplified all of these numbers, we kind of crossed them out and simplified them, we can still actually simplify this result, because the number 6 actually goes into 30 and it goes into itself. So we can divide these one more time. We can divide 30 by 6, because 30 divided by 6 is 5, and 6 divided by 6 is 1. And 5 divided by 1, if we do that math, 5 divided by 1 is actually just 5. So now that I look at it, back here on this step, I could have just did 30 divided by 6, right? What's 30 divided by 6? It's 5. But either way you do it, as long as you're simplifying the fraction correctly, you'll end up with the correct answer. So that's multiplying fractions, and I would recommend you do it this way, especially for some of the longer homework problems that use larger values. Because even with the calculator is not going to turn all of this into a fraction. Most likely it'll give you a decimal. In this case, it might just give you 5, but in some of the other problems, it'll give you a decimal, whereas the homework assignments will most likely ask you for a fraction. Right, so these are just practice problems for simplifying fractions. If you're not 100% comfortable simplifying fractions, I would recommend you do these 3 problems, and I'll explain them step by step in about 5 seconds. So feel free to stop the video at any point. So for this first problem, we have a 5 in the numerator and a 10 at the denominator. Since we're simplifying it, we got to figure out what number goes into the top and the bottom. But that number would be a 5. We can divide both the top and the bottom by a 5. What's 5 divided by 5? It's a 1. It's 10 divided by 5. That would be a 2. So we end up with this fraction of 1/2, which is correct. Now if we move on to the next fraction, we can do the same thing. What number goes into 6 and 12? That would be the number 6. 6 divided by 6 is 1. 12 divided by 6 is 2. So we end up with 1/2 again. And this last example, what number goes into 27 and 18? That would be the number 9. And 27 divided by 9 would give you 3. 18 divided by 9 would give you 2. So that would be your answer. Now the very last thing I want to point out is, let's say that you choose what's considered to be the wrong number. Like in this case, we could have actually chosen the number 3. Right? We could have chosen the number 3. Because 27 divided by 3 is 9 and 18 divided by 3 is 6. This answer is not wrong, it's just not simplified all the way. Because at this point, we can kind of repeat the process. We can pretend like this is our problem and we need to simplify it. Well, what number goes into 6 and 9? That would be 3. We can divide both of these values by 3. How many times does 3 go into 9? 3 times. How many times does 3 go into 6? 2 times. So you do need to be a little careful on what number you choose. We always want to choose the largest possible value that fits into the numerator and denominator. Otherwise, you'll come up with this situation in which you have to simplify the fraction one last time. Hopefully this was useful. If you have any questions, again, feel free to reach out to me and I'll be more than happy to kind of elaborate on this idea.